Okay, I'm going to post pictures of these solutions just so you have them as like a document to look at. I'm not going to go through them all now because in general they were answered really well. There was just a couple of little things that came up quite often. A few people in this one here worked out the angle to the 50 degrees, or sorry, the 50 Newton force rather than the 70 Newton. So just be careful whenever you're reading the question. Let me see. And then I think it maybe happened again in this one, working out the wrong angle. It asked to the horizontal. See the way in the answer space it says to the horizontal. I think a couple of people give that to the vertical. The one that I do want to spend a bit of time going over is this very last one. So these first few parts we did do well in, but I'm going to go over the whole thing, right? So the displacement between Newtonard's airfield and Enniskillen airfield may be taken to be 114 kilometres. So I've marked that on my diagram as I've been doing this. At 250 degrees measured clockwise from north. So see the way that's 250 there. I used the fact that I took that away and ended up getting that wee angle there was 20 degrees. So sorry, I described that terribly. I took the 250 away from a 3/4 of a turn, which would be 270, to get that wee angle there would be 20 degrees. Okay. Difference between distance and displacement. All you have to say there is displacement has direction and distance doesn't. Then here, calculate the perpendicular components of S, the displacement vector, between Newtonard's airfield and Enniskillen. So if I go back up here, this is going to have a horizontal component of 114 cos 20. So going across to the west here. And then it's going to have a component vertically down the way, so south, of 114 sine 20. So that's just the working out there. A couple of people will, I think, put the angles here. Perfect. No worries with that. Right, part C. Oh, I do want to say something with this bit. On a day with no wind, a pilot starts the plane flying on displacement vector S, so that one that was marked on the last diagram, and does not then adjust the plane's controls. Calculate the journey time between Newtonards and Enniskillen, and then it gives you the average speed. So because that's the average speed, you can just use speed equals distance over time. Loads of people got 2/3 of an hour here, but then just wrote 0.6, and that'll be because your calculator will have done the 0.6 with the wee dot on it. Just watch out for that, because that obviously would round to 0.7 because it's 0.666 forever. So just be careful, right? That's why I don't like that. One of the reasons I don't like that setting on the calculator, because it can lead to silly mistakes like that. Now, the last part here did cause people some confusion. So on another day, the pilot undergoes the same journey, only this time there's a wind blowing with a constant speed of 36 kilometers per hour at 90 degrees to the displacement vector. So this is where he wants to go, but the wind is pushing down this way at 90 degrees. Okay, so calculate the new average speed and direction the plane must fly if it is to follow the original flight path S and reach Enniskillen in the same journey time, and also state the angle to the displacement vector S. So if the wind is pushing him down here and he wants his overall, like he wants the resultant of the wind and the way he's going to be this, he's going to have to go like up this way a bit, and then the wind's going to push him down so that the resultant ends up being this one. Right, now here's my wee diagram. You can see I drew it wrong the first time as well. So this 171 kilometers per hour, which was the information from up here, so he wants his resultant velocity to be 171 kilometers per hour this direction, right? But so he's going to have to head up here, so that this 36 kilometers per hour means overall it ends up like this, right? So this is one of those ones where the resultant isn't the hypotenuse, and that's why it's awkward. So once you get your head around that, and I would say I always think it through literally, like if I want to end up going towards you here, but there's a wind blowing in from this direction, well, if I aim towards you, the wind is going to push me over and I'm going to end up going over that way a wee bit. Whereas if I take account of the fact that the wind's pushing me that way a wee bit, I can aim over here and the wind will push me, and then I'll end up going towards you that way. Okay, so it's the same idea. So 36 kilometers per hour is the wind. We know overall that has to give us this, and then he has to fly at this direction. So there's my working out over there, because the unknown is the, what do you call it, hypotenuse. X squared is 36 squared plus 171 squared. Solve that and you get that. So 175, and then just work out that wee angle, because it said the direction from the displacement vector S, and that was the original 171. So it's this wee angle here we'll have to work out. So it's going to be O over A 36 over 171. And we get that. Okay, but in general, those were really well done. So happy days.